All right, my dear geometry students, this is lesson 6-7, and it is titled Distance on the Coordinate Plane. 6-7, Distance on the Coordinate Plane. It's on page 262 in print, and it starts on page 262 straight up in Braille. 6-7, Distance on the Coordinate Plane. It starts out with the what'll you learn, and it says you'll learn to find the distance between 2 points on the coordinate plane and why it's important. They discuss how you can know with transportation how to find distance between 2 points that can help you determine distance traveled. So that's what it starts out on page 262, 6-7, Distance on the Coordinate Plane. All right, so then it goes on to state in lesson 2-1, you learned how to find the distance between 2 points on a number line. In this lesson, you will learn how to find the distance between 2 points on the coordinate plane. When 2 points lie on a horizontal line or a vertical line, the distance between the 2 points can be found by subtracting one of the coordinates. In the coordinate plane below, points A and B lie on a horizontal line, and points C and D lie on a vertical line. So, Braillers, if you turn the page to 262A, print users were looking at the coordinate plane directly below that paragraph of information. It's going to walk us through, we're going to walk through how and remind ourselves how we could find the distance between 2 points when they're just a straight line, either horizontal or vertical. They either have no slope or undefined slope. So AB, points AB, A is in quadrant 2. So find your X and Y axis. So X runs horizontally. You have 2 arrowheads in the midst of your page with a heavy dotted line in between, and they're labeling it X to the right of it. And then a heavy dotted line running vertically on your page with 2 arrowheads top and bottom at the 12 o'clock and 6 o'clock position. And they've labeled that your y-axis directly above it. And then they've labeled where they intersect the origin, right in the middle. So if you go to quadrant 2, you will find a point at 1, 2, 3, -4, and 1, 2, 3, -4, 3. There is a point. And they're labeling that point A, open paren, -4, 3, close paren, directly above and to the right of it. If you follow that point immediately right, no slope, horizontal line, you will come to another point in quadrant 1 and they're labeling that point B at 1, 3. So we have 2 points, A and B, and the distance between those 2 points, if you counted the number of cells, the grid pattern between them, you would have 1, 2, 3, 4, 5, or directly below the line, there's a little brace, and it says 5. So it's 5 units long. We could also figure it out based upon the coordinates. Because this is a horizontal line, it's having to deal with the x coordinates. So we could find the difference between -4 and +1. -4 minus 1 is -5, and the absolute value of -5 is 5. So there's 5 units between those 2 points. We could either count them by hand or do the math. Now find another point in quadrant 1 at 1, 1, coordinate 1, 1. They're labeling this point C, open paren, 1, 1. Go directly below, directly south of that point, and find a point in quadrant 4 at 1, -3. And they're labeling this point D. If we wanted to find the distance between these 2 points, we could either count them, 1, 2, 3, 4 units between point C and D, or because it's a vertical line, it's running parallel to the y-axis, we could find the difference between the y coordinates, 1 and -3. What is the difference between 1 and -3? That's the same as 1 minus a -3. So if we have a minus negative, that actually means plus. So 1 plus 3 is 4. So this is 4 units long. So that's reminding you that to find distance, you could just subtract your coordinates if it's a flat line, if it's horizontal, or if it's a vertical line. We're going to prove how we can do something kind of similar, but using the Pythagorean theorem on the next graphic. So turn the page, 2 pages, Braille users, and we're going to look at another coordinate plane, and we're going to discuss how we could figure out how to find the distance between 2 points if it's at a diagonal, if it has a slope other than 0 or undefined. It's not as simple as just finding the difference between the 2 points. We have to find the square root of those differences, the square of those differences. We have to use the Pythagorean theorem. So let's take a look at that and see what's happening. So we have a coordinate plane right in the midst of your page. So you have your y-axis going up and down, 2 arrowheads, labeling it y just up above it, and your x-axis horizontally right in the midst, going left to right, 2 arrowheads, and they label it with an X. The origin's labeled with an O. In quadrant 1, there are 2 points. There is point C at 2, 3. So 2 spaces over to the right, 3 spaces up. There's point C. Directly below that, 2 spaces, is point B. That's at 2, 1. There's a right angle indicator, so it's reminding you that from C to B is a perpendicular line. From B, you move immediately left, parallel to the x-axis, to point A in quadrant 2. And that is at -3, 1. So CB is perpendicular to segment AB. And then from A in quadrant 2 back to C in quadrant 1, there's a heavy dotted line connecting those 2 points. So we can figure out the distance from C to B is 2, isn't it? And the distance from B to A is 1, 2, 3, 4, 5. Or we could take the 2 and minus a -3, and we would get 5. But how do we find it from A to B? We can't just count anymore because we've got this angle and we're not at an exact 45-degree angle, so we're not taking up an entire unit. We can kind of come close. We can't just subtract the x coordinates or the y coordinates because all we would get then is the slope. We wouldn't get the distance. We would get the rise over run, right? y2 minus y1 over x2 minus x1. So we would get the slope, but we still would not get the distance. So how can we get the distance? Well, if you feel the outline of this ABC, it's a triangle, isn't it? And CB and AB are perpendicular to each other, so what kind of triangle is it? Hopefully you're saying it's a right triangle. Well, you just learned to find any one side of a right triangle, you can use the Pythagorean theorem. A squared plus B squared equals C squared. So we could use a leg squared plus a leg squared and find the hypotenuse squared. So to find this hypotenuse squared, we could take the distance of one of our legs and square it, and the distance of the other leg and square it, and then do the square root of that, and we have our hypotenuse. That is the middle school lunch bell. Sorry for that interruption. There will be 2 more bells in the next 10 minutes. So if you turn the page, and it says there's a page break for 263 on the next page, right in the midst of it. And it says, in that activity, we found that AC squared equals the square root of AB, or the AB squared plus BC squared. So if we take the square root of each side, we determine that our hypotenuse, AC, equals the square root of AB squared plus BC squared. So that determines the next formula, which is called the distance formula. And it looks really crazy, but it should make sense because it's the run squared plus the rise squared. Then we find the square root of that to get the distance of our hypotenuse. So the next Braille page, 263A, shows that theorem, the distance formula, theorem 611. It says if D is the measure of the distance between 2 points with the coordinates of x sub 1, y sub 1, and x sub 2, y sub 2, then the distance formula equals distance equals the square root of open paren x sub 2 minus x sub 1 close paren squared. We got to take the difference between our two x values to find its distance, its measurement, the measurement of the leg. Then we're going to square it. Then we add it to open paren y sub 2 minus y sub 1 squared. That's the distance of our other leg, and we square it. We add those two together, and then we square root it, and we end up with the distance of our hypotenuse, the distance between those 2 points. And in a graphic, they just show the x and y axis. So find that. And then in quadrant 1, there's a point B, labeled x sub 2 comma y sub 2. And then in quadrant 2, there's point A, labeled x sub 1, y sub 1. And between those 2 points, they have a line. So we're finding the distance between those 2 points by using the distance formula. The difference of our x values squared plus the difference of our y values squared, and then square root that. Use our Pythagorean theorem just kind of reworked. So it's pretty impressive the way it looks, the formula looks, but if you just really think about it, all it is the Pythagorean theorem. So turn the page and there's an example. We can use the distance formula to find the distance between any 2 points. And so example 1 says, use the distance formula to find the distance between J at open paren -8, 6. I'm going to use a whiteboard to write this out for my visual learners. So we have point J at open paren -8, 6, close paren, and then point K at open paren 1, comma, -3, close paren. So using our distance formula, we can replace all those values with these coordinates, do the basic algebra, and solve for the distance between J and K. So first, in the example, they write out the distance formula. D equals the square root of open paren x sub 2 minus x sub 1 close paren squared plus open paren y sub 2 minus y sub 1 squared. The next step, that's the distance formula. The next step, they substitute in all the values. So the D actually is JK because it's the distance from J to K, and that equals the square root of 1, open paren, 1 minus a -8, close paren. Now this actually says in your book open bracket because it uses a paren around the -8. So open bracket 1 minus open paren -8 close paren close bracket all to the power 2. Bring it on down with a .5 in Braille plus open paren y sub 2, which is -3, minus y sub 1, that's the second bell, the high school lunch bell, minus 6 close paren to the power 2. So we just use the substitution property in order to do that. Now we do all the math. We do our subtraction. We use our order of operations, right? We do our stuff in our parentheses, and the next line has JK equals square root of 1 minus a -8 is actually 1 plus 8. So 9 squared plus negative 3 minus 6 is negative 9, right? So open paren negative 9 squared. And that's just using doing our order of operations and doing the subtraction. Then we have jk equals square root of 81 plus 81, because 9 squared plus negative 9 squared is 81 plus 81. So we do our squaring, our exponent rules. Then we add those two together, and jk equals the square root of 162. That's not a perfect square, so we have to do a little bit of calculator work. We have the square root of 162. So jk is approximately equal to 12.7. If you put that in your calculator, so you do 162 square root, you get 12.727922, and round it to the nearest tenth, it's 12.7. So the distance between j and k is approximately 12.7 units. Right? And that goes through the entire kind of proof of doing it, using the distance formula, using our substitution property, using subtraction rules and exponent rules and addition rules, and then square rooting to simplify. All right? So there's two examples under the your turn after this. There's a little a at the very bottom of the page where m is open paren 0, 3 close paren, and n is open paren 0, 6 close paren. You could find the distance between m and n using the distance formula and following the steps in the above example. Find the difference between your x's, 0 minus 0. Find the difference between your y's, 6 minus 3 is 3. Square them. So 0 squared is 0, 3 squared is 9. Add them together, 0 plus 9 is 9, and then square root that, 3. The distance between m and n is 3. So there's another your turn, little letter b on 263c. And that has 2 points, g at open paren negative comma 4 close paren, and h at open paren 5 comma 1 close paren. Again, you use the same distance formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. You figure out all those differences, the differences between your x's, the differences between your y's. You square each one of them, add them together, and then square root them, and you find the distance. All right? Now, the next page, there's a page break, 264 in Braille, and turn the page, print users. You can use the distance formula to determine whether whether a triangle is isosceles or equilateral, or maybe you determine it's scalene. You could be given 3 points, and you figure out the distance between those points 3 times. So if you're given point A, B, and C, you would figure out the distance between A and B. You would figure out the distance between B and C, and then you would figure out the distance between A and C. So you would do the distance formula 3 times, and then you would compare your answers. If all 3 answers are the same, you have 3 sides that are the same, you have an equilateral triangle. If 2 of the answers are the same, and 1 is different, 2 sides are congruent, you have an isosceles triangle. If all 3 sides are different, you have a scalene triangle. So the next example, example 2, walks us through determining whether a triangle with certain vertices is isosceles or not. So it says determine whether triangle ABC with vertices, and now it's time for a lunch bell. Determine whether triangle ABC with vertices A, open paren, negative 3, 2, B, open paren, B, comma 5, or 6, comma 5, and C, open paren, 3, comma negative 1 is isosceles. So they show that you have to find AB. So the square root of 6 minus a negative 3 squared plus 5 minus 2 squared. They take the points from A and the points from B, and they find the difference in the x values, the difference in the y values, square them. So 9 squared plus 3 squared. So 81 plus 9 is the square root of 90. And they just leave it at the square root of 90. This is all on the next Braille page 264A. So we leave it at the square root of 90. I mean, we could figure it out if we want to, but we just want to leave it at that for now and see what we get for the next one. So then they do BC. So they plug in the values for BC. B has 0.65, C has 0.3, negative 1. So the difference in the x values would be 3 minus 6. The difference in the y values would be negative 1 minus 5. So we get negative 3 squared plus negative 6 squared, or 9 plus 36. So we have the square root of 45. So far we're like, okay, well, we've got one side at the square root of 90, one side at the square root of 45. So we better move on and see what we have for AC. So they do the next 2 points AC. They plug in all the information, the values for A point, the values for C point. So the difference in the x values. 3 minus a negative 3. Aha, that's 6. 6 squared. Negative 1 minus a 2 is negative 3. Negative 3 squared is 9. So 36, 6 squared is 36 plus 9, square root of 45. Okay, that's good. We've got two sides, AC and BC are 45, square root of 45. They're the same length. And then we have a line that is not. So this is an isosceles triangle based upon using the distance formula to prove whether the measures are congruent or not. If they were all different, you would say, nope, it's not an isosceles, it's a scalene. If they were all the same, you would say, well, yes, it's an isosceles, but more specifically, it's an equilateral triangle. The next example, example 3, walks you through a story problem that has to do with distance, and this is where mapping comes into play and using the distance formula to find the distance between 2 points. It says, Lena takes the bus from Mills Market to the candle shop. Mills Market is 3 miles west and 2 miles north of Blendon Park. The candle shop is 2 miles east and 4 miles south of Blendon Park. How far is the candle shop from Mills Market? So thinking in terms of east and west as your x-axis and north and south as your y-axis, and if it says it's coming from Blendon Park, you could think of that as your origin. So 3 miles west would mean negative 3, and 2 miles north would be a positive 2. So your point is at negative 3, 2. And then the Mills Market, or the candle shop, the candle shop is 2 miles east, so a plus 2 on the x-axis, and 4 miles south, so a negative 4 on the y. They show a drawing, they gridded it out on the next Braille page on 264C. There's a grid and a coordinate plane with your y-axis and your x-axis. So the y-axis running north and south, right? And they even mark that an N for north and then a little y. And then east and west is your x-axis, right? And they have a W on the left-hand side for west and an E on the right-hand side for east, and then they also label it an X for the x-axis. And then down at the bottom, underneath north, there's an S for south. So it's a cardinal points. Blendon Park is the origin, so they're labeling that BP next to the origin, but they also label it an O. And then there's a point that is 3 miles west and 2 miles north. So 3 to the left and 2 miles up. That's our Mills Market. So open paren, negative 3, comma 2, close paren. That's Mills Market, MM. And then down in quadrant 4, we have the candle shop, which it says is 2 miles east and 4 miles south of Blendon Park. And Blendon Park is our origin. So 2 to the right and 4 down gets us our point of the candle shop, CS, they're using the abbreviation. So open paren 2 comma negative 4. And then they put a dotted line between those 2 points because we could figure out the exact distance between those 2 points if we went diagonally to go between the two. So the next page walks you through, next Braille page walks you through the proof of it and the work. In print, it's just below all that information. So it says D equals our distance formula, the square root of x2 minus x1 squared plus y2 minus y1 squared. We plug in the values of our points. So 2 minus a negative 3, those are our x values. Positive 2 to the right and negative 3 to the left. So 2 minus a negative 3 is 5. Then we plug in our y values. Negative 4 minus 2. Negative 4 minus 2 is negative 6. So then we square them. 5 squared is 25. Negative 6 squared is 36. 25 plus 36 is the square root of 61. Plug that into your calculator. The square root of 61 is approximately 7.8. And they use an approximately equals for the 7.8. And approximately equals typically is a .4156 twice, or sometimes it's a .4156 and then an equal sign. It just depends on whether you use 2 tildes, which is a .4156, or 1 tilde and an equal sign. All right? So that's using the distance formula to do a story problem, which usually these formulas have to do with finding distance between 2 places. That would make sense. So here's a distance between 2 places. So that takes us through lesson 6-7 on the distance formula. It would be really helpful if you went to the Check Your Understanding on page 265 and worked your way through number 1 through 29. That takes you through lots and lots of practice of using the distance formula and using it with story problems. Each time, write the distance formula out. D equals the square root of open paren x squared minus x1 close paren squared plus open paren y2 minus y1 close paren squared. If you write that out each time, you'll remember it. And then that way, when you come to have to use it on an exam or the end of course exam, you'll just have it in your brain. You'll be like, oh yeah, I got to use the distance formula. You'll find the difference between your x values and square them, the difference in your y values and square them, add them together, and then square root them. That's the Pythagorean theorem. The square root of a leg, or excuse me, the square of a leg plus the square of the leg equals the square of the hypotenuse. In order to find that, we got to do the square root. So instead of showing that a squared plus b squared equals c squared, they just show it all at once. It's the square root of the square of the measurement of each leg added together. Right? Happy practicing this, and that's the end of chapter 6. I would advise also to practice and review for chapter 6 that you back up and view or listen to all the videos from 6.1 to 6.7 to review all the concepts in this chapter. It was pretty long. It had a lot of information. All right, we'll see you in the next video.